Welcome to this new lecture of the C++ programming. In this lecture we are going to discuss the memory allocations during the execution of the program to the variables or to the functions inside the memory. Okay, so we have four types of memory allocation in the execution of the program. Okay, so first is the stack, second is the heap, third is the global, and fourth one is the coding or the text that you have written in your editor. So we will see in this lecture that how stack and heap are created and how these both allocations are managed together while execution during your program. So let's talk about the stack. In computing, a stack is a data structure used to store a collection of objects. The individual items can be added and stored in a stack using a push operation. Objects can be retrieved using a pop operation, which removes an item from the stack. When an object is added to a stack, it is placed on the top of all previously entered items. When an item is removed, it can be removed from the top of the stack. A stack in which items are removed from the top is considered as LIFO, L-I-F-O, last in first out stack. While the heap is actually totally different from the stack. Okay, so it is created with full of liberty in the memory, and we will see how the heap are created. While the global stack is advanced topic, and we will see it in the object-oriented concept, where we use actually the static concept of declaration or definition of different variables or the user data types. And the code is actually the code which you have written as actually placed in the memory, resides some place in the memory. Okay, so this is a very small example of a main function in our program. So when it start execution, the processor follow the concepts defined in the operating system, actually allocate or create the stack in the memory. So there will be a stack created in the memory with a name main. So it means that this stack, this allocation or this space in the memory is reserved for the main function. Now we can push the items inside the main function to the stack and pop all the items from this stack while its execution is being finished. Okay, for example, if we have declaration of the variables inside the main, so all those declaration in initialization will be saved in the stack. Okay, so if in the first statement we have declaration of integer a is equal to 10, so that a variable will be placed and the space for this a will be reserved inside the stack. So we will have a is equal to 10. Okay, so in this follow the principle of the stack. Through this way we will push all items, all declaration and variables, even the calling of the function into the stack. So let's see example of the calling function. So for function, you will see that a call of the function has been reserved inside the stack, and for that function the processor will allocate and create another stack inside this stack for this calling function. So this will be the place for the calling function. So any other declarations that have been done in the function definition, all those will be reserved inside and will be located inside this place of the stack. Okay, so in this manner we are creating and lengthening or increasing the size of the stack by pushing the items inside the stack, and these items will be popped out once the execution of each item is completed inside. Okay, so this is how stack is managed inside the memory by the processor. Okay, so let's see now discuss the heap concept. Heap is actually a totally different concept of the of the memory allocation inside the using C++ language. So here you can see there is a very free space inside the memory in which we can create some objects, some declarations in initialization using the new keyword. Okay, so any object created with the new keyword, that object will be actually, be placed in the heap, not in the stack. Okay, and then there should be a type, maybe user data type or primitive data types. Okay, so this is an example. In the second line, you can see the new space, integer, and the brackets. Okay, so the brackets are actually shows the constructor inside the class. Okay, so when you use the new keyword, so there must be a calling of a constructor for any data type. Even if you use the pointers, primitive data types, or user data types, for example, the structure even. Okay, so you need to call the constructor of that class. So now integer is a class type. Okay, the integer type, its size is 4 bytes. Okay, it's a primitive data types, so there is no difference of this calling constructor and the simple integer. Okay, simple integer is used to declare a variable, while the constructor integer is used to create an object of type integer. Okay, with no name or no identifier. Okay, so this line is actually creating an object of type integer inside the heap with no name and with no identifier. Okay, because we have not assigned this object to any variable. Okay, so if you use, for example, integer space a, so it means that you are creating an object of type integer, but that object will be named as a, and for this, this will be saved in the stack portion of the memory. Okay, while this, when you use the new keyword along with the constructor of type, so this will create an object in the heap, not in the stack, without any name. Okay, so now the object has been created, but the question is, how can we assign this object to some variable so that we may access to this object? Okay, because we cannot access in our coding to that object. Okay, even if you write cout, so how now I can access this object? So we have no reference variable or no variable or no pointer variable so that we may access to this object in the memory. So what should we do now? We can declare, because this is an object type and every object has some address. Okay, for example, the address of this object has 700. Okay, always remember that the addresses of each location in the memory are in type hexadecimal type. Okay, so this is just for example purpose here. Okay, so 700 is the address. So now what kind of variable are responsible to save the addresses? The pointers actually. Okay, so let's see. Integer, because this is of integer type object, so therefore the address of this can be assigned only into the integer type pointer. Let's see p as the variable name with a pointer of type integer. So in this way we can assign, creating a new object of type integer. Okay, so just ignore now this statement. Okay, so this statement will create an object inside the heap and the memory, and the address of that object will be returned and will be saved in a pointer p. Okay, this pointer belongs to the stack. Okay, so p will be saved here with some value, and that value will be 700. It means that this p is pointing to somewhere else in the heap, in the memory, which has object of type integer. Okay, so now we can access through this p to the object which resides inside the heap. Okay, and now we can assign values inside the this object using P. For example, dereference operator P is equal to 10. So it means that we are going to assign 10 into dereference this address, which is this one, and assigning the value 10. Okay. In this way, you can create many or different data types, new objects in the heap while using the new keyword. Okay. But remember that for stack, the processor or the operating system actually push in, pop all the items from the stack, and it becomes empty at the end of the execution of main program. Okay. While the case for the heap is totally different. Even if your program is stopped, is finished, even though your object in the heap will be reside and will be live. Okay. So this it becomes the leak of the memory. So normally this is not considered a very good programming, to use the new keyword while not deleting the object in the heap. So it means that this heap is managed by the programmer. Programmer create the objects, and programmer should delete those objects at the end of the execution of the programming, or the main program, or the whole program. Okay. While for stack, programmer is not responsible. For stack, the processor will empty the stack at the end of the your main program. Okay. So what should we do now? We can simply use the keyword delete. So we can use the delete keyword to delete the object to which P is actually pointing. So this delete keyword will not delete the P. Okay, remember, this will not delete the P, but actually this delete keyword will delete the object which resides on the address, saved in the P. So the address inside the P is 700. So 700 is is pointing to this location, and this location has object of type integer. So there is an object there. So that object can be deleted using delete P. So it means that we are deleting this object now. Okay. But you have noticed that still this P is pointing to that address 700. Okay. So it means this P is pointing to a space in the heap which does not have any value or object. So this is now a problem, that P is pointing to somewhere in the memory, but that place has no object now. So this problem is known as the dingling pointer problem. Okay, the dingling problem of a pointer which actually points to the location, but that location has no object. So what should we do now? Now the P can be assigned with a null value. Okay, P is equal to null. So it means that this value will be replaced with null, and we are going to delink the space. Okay, so we are actually removing the dangling problem of the pointer in the programming, so that we may not use P illogically. Okay, so in this way you can assign you see, we can assign a new object to the pointer P with some initialization of a value inside the constructor. So it means that this P now, that this P shall now be pointing to a new object inside the heap created somewhere else, okay, and the address of that object is now 500 or maybe some other, okay, and we are initializing the value inside that object is 5, and the address of that newly created object is assigned to the pointer, so the address of this object is now 500. So this P is now pointing to the newly created object inside the heap. Okay, so with the new keyword we are going to create new objects inside the heap, while using the delete keyword we delete the objects created inside the heap using the pointer variable. Okay, so if you want to delete this object inside the heap, so we need to delete, to write a delete keyword and then P. So it will delete the object, okay, and it will not delink the P. It will not delete the address of inside, saved inside the P. Okay, so for that you need to assign P with null. So in this way you're gonna change the value of P. So it means that you are going to delink while you are also deleting the object using this operation, the delete operation and the assigning null value. Now this is a very small example of user defined function with new keyword creating a new object and assigning that into a pointer, but while we are calling this user defined function from the main function. Okay, so here you can see we have called this function from the main function. Okay, so for this main function we will see a stack memory allocation. The stack will be created for the main function, and in that main function we are going to create or call the user defined function. So for user defined function there will be a portion inside the stack of the main, and that will also be a substack for the user defined function. In the user defined function you can see we have declared a pointer P, and that P will save an address of any object of type integer. So we are creating a new object of type integer inside the heap because we have written the new keyword. So in this way we are creating a new object inside the heap, not in the stack, and we are also initializing 4, the value 4 in that object. Okay, so this object has value now 4 and the address, for example, 200, okay, in the memory. So it means that this 200 address will be assigned to the pointer. So you can see this value has been assigned to the pointer, so now this pointer is actually pointing to the object inside the heap. Okay, so the rest you can then play with the pointer, and the object you can also delete, and you should delete the object that you have actually created using new keyword. So in this way you can create an object inside the heap, and you must delete the created object inside the heap using the delete keyword. So if you have any question regarding the heap and stack, so please ask me just below in the comments. Thank you very much.